let's talk about something that drives every single one of us developers absolutely crazy. You've poured your heart and soul into building this beautiful, functional application. You go to load a big chunk of data, and the whole thing just stops.
Oh, you know that feeling, right? It's that sinking moment where your slick, professional app suddenly feels clunky and amateur. The screen flickers, the app freezes, and you get that dreaded not responding message. Well, what if I told you the fix is usually just 2 lines of code? Today, we're going to turn that sluggish UI into something incredibly fast and responsive. All right, first up, let's properly diagnose the problem. We're going to investigate the crime scene, the flicker, and the freeze. This is that moment your app's performance just hits a brick wall. And you know, every good investigation needs a smoking gun. For us, it's this, the dreaded application not responding dialogue. This is the undeniable proof that something has gone horribly wrong deep inside our app's logic. But what's actually causing this catastrophic failure? So, let's pop the hood and really unmask the performance culprit here. We're going to see exactly what's causing our beautiful application to lock up solid. So here's what's actually happening, and honestly, it's kind of brutal. When you're in a loop adding items one by one without any optimization, this is the vicious cycle you create. For every single item you add, the UI control feels this obligation to completely repaint itself and then send out a whole flurry of notifications to anyone who might be listening. It does this on every single pass, forcing the screen to redraw itself over and over and over again. Now let this number sink in. If you're loading 10,000 items, you are triggering 10,000 separate, incredibly expensive repaint cycles. This is the bottleneck. For 10, 15, sometimes 20 seconds, your UI thread is just completely pegged at 100%. The screen is frozen solid, and your user, they're just sitting there, clicking around, wondering if your app just crashed. Okay, enough of the problem. Let's talk about the solution. And trust me, it's so simple, but it's an absolute game changer. We're going to call it the Do Not Disturb secret. The magic here really comes down to 2 little methods, begin update and end update. The best way to think about it is like putting a Do Not Disturb sign on your component store. When you call begin update, you're basically hanging up that sign, telling the UI, hey, look, I'm about to do a whole bunch of work in here. Just ignore me. Don't redraw, don't send notifications. I'll let you know when I'm done. You can then add thousands of items and the UI won't even bat an eye. Then when you're all finished, end update takes the sign down, and that's the signal for the UI to do one single hyper-efficient repaint that shows the final result. And look, this isn't just theory. Check out these real-world numbers from loading a couple thousand items into a FireMonkey list box. Without our pattern, it takes a painful 25,000 milliseconds. That's 25 seconds of a frozen app. But with begin update, it drops to just 125 milliseconds. It's not even a fair fight.
Yeah, let that sink in. A 200 times performance boost. We're not talking about some tiny incremental optimization here. We are talking about the difference between a totally unacceptable 25-second wait and something that feels completely instantaneous. This is the line between an app that feels broken and one that feels incredibly polished and professional. So you might be wondering, how does this magic actually work? Well, under the hood, the VCL and FireMonkey frameworks actually pull this off in 2 totally different ways. The VCL, since it's basically a thin wrapper around the Windows API, can send a special message directly to the operating system telling it, hey, just stop painting this control for a minute. FireMonkey, being cross-platform, has its own rendering engine, so it uses an internal counter, kind of like a semaphore, to just tell its own engine, hold on, we're updating, wait till I say go. So, 2 different roads, but they both lead to the exact same destination for you as a developer. A super fast, flicker-free UI. All right, now listen up, because this next part is maybe the most important thing we'll talk about. This isn't a suggestion. This is the unbreakable golden rule for writing stable, robust code.
You have to, and I can't stress this enough, always wrap your update code inside a try finally block. No exceptions. Begin update goes right before the try, and end update goes inside the finally block. This structure is completely 100% non-negotiable.
And here's exactly why this is so critical. Just think about it for a sec. What if some unexpected error pops up while you're in the middle of adding all your items? Your code throws an exception and jumps out of the procedure. If that happens and you don't have this structure, end update never gets called. And your component? It's now a permanent ice sculpture on the screen. The Do Not Disturb sign is stuck on the door forever. The finally block is your safety net.
It guarantees, no matter what happens, that end update will always be called, bringing your UI safely back to life. Okay, so you've mastered the basics. You're using the lock pattern everywhere. Let's level up and talk about some advanced tactics for those trickier situations and when you're dealing with truly massive datasets. Sooner or later, you're going to run into a component like tStringGrid and realize, wait a minute, there's no begin update. So what do? Well, the accepted workaround is to just iterate through each of the columns and call begin update on them individually. And here's another pro tip for you that works with any list. Before you even start your loop, set the .capacity property. By pre-allocating all the memory you're going to need, you stop the list from having to constantly stop, resize itself, copy data, and start again. That can be a huge hidden performance killer. But what if you're dealing with just massive amounts of data? We're talking tens, even hundreds of thousands of items. At some point, even begin update isn't enough. Well, that's when you bring out the big guns. You go virtual. And this table just lays it all out perfectly. A virtual control works on a completely different principle. It doesn't actually load all 100,000 items into memory. Instead, it just tells the control, hey, there are 100,000 items in the list. That's it. Then, as the user scrolls, the control comes back to your code and asks, okay, I'm about to show item number 50,005. What text should I display? You provide the data just in time, only for the handful of items that are actually visible on screen. The result? Loading is instantaneous, and memory usage is incredibly low. It's just a brilliant approach. Whew! Okay, we have covered a ton of ground. So let's pull all of this together into your official performance playbook. This is the actionable checklist you can take to your very next project. Here it is, your 5 essential rules. Rule number 1, and I'll say it one last time, try finally, always. Number 2, do your heavy lifting, your database queries, your complex calculations, before you even call begin update. Get the data ready first, then update the UI. 3, know your escalation path. Start with begin update, move to more powerful locks if you have to, and know that virtual mode is your ultimate solution. 4, remember to pre-allocate capacity. And finally, number 5, especially in FireMonkey with its complex styling and layout engine, be extra generous with your update locks. Sometimes you need to lock more than you'd think. And that really brings us to the final question, the big one. Because when you get right down to it, optimizing your UI isn't just about making numbers go down on a benchmark. It's about craftsmanship. It's a fundamental sign of respect for the person on the other end of the screen. It's about respecting their time, their patience, and their attention. So take a hard look at your code and ask yourself, is it